Hello, hello. Adventure George, hi. Glad to see you here. Okay, so today it's gonna be a debugging stream. So basically I have a problem somewhere in the server. I believe this piece of code is not working correctly. Basically what's happening is when you receive a bunch of packets and the last packet is not complete, so I have like only a portion of it, looks like something breaks and the server, instead of reading when the rest of the incomplete packet gets delivered, looks like it's reading from the old memory. So I'm not sure what's happening there, but we will need to debug that. And this is really hard because I can only reproduce this problem on a real network and on a real server, because only in that way I can have like incomplete packets, at least with this like client and server. So to basically reproduce this problem, I need to write a custom client that would simulate what's happening in the network. So basically, I have a Hello World app that I created just now. And what I'm gonna do is I'm gonna basically create a very simple TCP client using like default C# tools. So there is like a built-in TCP client. This one. Can you use the user? Oh my god. Okay, doesn't matter. So I need the host name, which is localhost, port 6401, and yeah, what's next? How do I send data? So I need to get the stream. So this client will only send few packets, it will not read anything. So this makes it easy for me. So client gets stream, and then stream write, and I need to basically write some packets. So new byte, and I have few packets already sniffed in Wireshark. So these two packets is basically where the problem occurs. This is sent by the client to the server. So here we have one packet. Yeah, so we have packets, then session ID, these four numbers, which is empty, then opcode, then two sequence numbers, which we don't care right now, and then the data. And the data is the int. And then, no, wait. I'm not sure what is this thing. But okay. 000E is basically the size of the packet. So it should be 14 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, and then, yeah, this is the next packet, which is incomplete. So let's simulate this. We have 0, 0E. Can I copy this? Escape string? No. Give me something useful. Hex string. Okay, this can be used. So this is the TCP portion of it. Oh wait. Yeah. 000E. So can strip that. This is my packet, and I can now just do that. Okay, this is fine. Then stream flush. So this is one packet. I guess I don't care about closing or something. Let's try and start the server and see what it says. Okay, I think all good. Just need to start login server as well, so you can see the traces of failed connections to the login server. Okay, so if I run it once again, yeah, connected and disconnected. So let's now here, I think, yeah, this heartbeat. Actually, Yeah, for some reason it doesn't work. What if I do that? Connected and disconnected. It's kind of... I want to receive a packet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh. 14, 15, right? No, still nothing. What? It should be this. Weird. Let's debug some stuff. Main, but oh, wait. Something's wrong. Let me check the configuration. So encryption is disabled. But what the hell? Wait, I think I know. Like it closes before it can process something, or? No. Okay, let's try and debug once again. So, state buffer. What do I have here? No zeros. Oh. Different offset. Okay, this is gonna be hard to debug. 261,000. 𝙽𝙴𝚁𝙸𝚂. Here, 014. Also, it can be that 1, 2, 3, 4, 5. It's 𝙽𝙴𝚁𝙸 for some reason. Has some kind of leading zero. I think this is the problem. This shouldn't be there. So this is the size. Then 1, 2, 3, 4 bytes. Then the opcode. Then this thing. And then this should be an int. Ah, okay, yeah, see, this was from the previous packet. Okay. Now this should work. Yeah, now I receive handshake procedure is not finished. Okay. So now I can just disable handshake validation for now for this packet. I will need this pause in a little bit. So let's run. Yeah, now I can see this. So now I can send multiple packets. Like for example, this 7 should be the next number. Yeah. So instead of this, I can just go with 0, 1, 0, 2, 0, 3, let's say. Oh, yeah, 0, 3. Yeah, now 3 tests, 3 test packets are successful. So now let's try and reproduce the problem. How can we do that? So I need to send an unfinished packet. So here was one unfinished packet, then another one started, and the third one was not finished as well. So what I can do is, I can send one packet, then this one will be unfinished. So this one will be in the next message. And then here, well, let's just try that. We still have to receive 3 tests. No. So all I did is I moved the byte here. And I think it already caused some problems. Let's double check. Yeah, test is successful. Then if I move this byte here, it shouldn't matter to the server at all. Okay, right now it works, but weird. Okay, here we go. 4 packets. Okay, this is really weird. So I already have some problem. 3 packets. So I already managed to reproduce this problem. This is great. Can I get rid of this one? So this one is correct. This one should be there. But now let's try make it display 2 errors. One? No, I still need that one. So this is the correct test case. Just need to figure out what's wrong. So the order of messages is correct, but I'm getting a 4th packet. So definitely something wrong. Okay, this is great. Now we can try and debug. This is gonna be painful to debug, but let's try. At least I have a proper test case now. So I have 13. So if it's negative, it means we have another packet incoming. Actually, wait. I think I should debug it in a different way. Something like that. Because the result is going to be different. Why did I stop debugging this thing? So we have 1 remaining byte 0. Yeah, now this is correct. And I can just wait here. So remaining bytes is 0. So we reset this thing. Yeah, now good. We finished. Then next packet. Remaining bytes is 1. So this one is an finished packet. We don't process it at all. Great. Now here, have remaining bytes minus 14, which means we have more data than we expect. Okay, and we have our first packet. I mean the second, first in this message. Thing is, this is weird, but well, I don't know. Weird because it was after the second message. Should be fine, theoretically. So maybe this one is wrong. But okay, let's try and see what's going on after that. So remaining bytes is minus 14. We received 28. So next packet of set is 14. Correct. And we're done. Now we go with the next one. Remaining bytes 0. The next one should be... Oh, somehow sent the number 3 already. Oh, yeah, this is fine. So the next one should be correct one as well. What do we have? Yeah, right now we didn't have any problems. Okay, let's try once more. So this is our first packet. Then this is our second packet, but with unfinished byte. We don't have packet here. Okay. Now the last one that on which we would have 2 packets received. Here we go, 1. Two. very weird. What's going on? Can't catch this bug now. Under debugger. Don't think there can be any race condition. Should be something else. Weird. Now I have only 2 packets. What? This is really weird. Hello, hello. By the way, how should I call you? 𝙽𝙴𝚁𝙸𝚂 or 𝙽𝙴, or how do you prefer? And yeah, I'm doing good. It's just going insane a little bit with this weird bug. So there's definitely something weird on the server, on the network side. Sometimes something weird going on and the server uses old data from the buffer that shouldn't be read, which causes a lot of problems if the user, well, it basically causes a disconnect if a user has some kind of weird connection issues. And I can't reproduce it right now under a debugger, but let's try once more. I'm just gonna skip everything. I only want to make sure that debugger is not because of this problem. Why does it have 2 tests? It should be 3. So the first one works. Have test for the first one. Then this shouldn't be a normal packet, yeah. And then here we should have 2. 1. Here should be 2. Yeah. Super weird. Come on. Just don't understand what's happening. First one. Then incomplete second one. 1, 2. Okay. something, 2, 3. So the basically there is a problem with how I read incoming packets on the server side. So here, for example, 3 TCP packets. They're basically identical, it's just there's different data in each one. So here is a 1, 2, and 3. And these are correct packets. And the way it works is TCP is not like really packet-based protocol, but it's stream-based protocol. So it doesn't mean, it doesn't matter how the data arrives in how many packets. It just appends to the previous one, basically. So we could send just 3 packets like this, one by one, and this is fine. But TCP also can split one message into 2 or combine 2 together. So it can do something like that. So basically 2 packets in a single message. And this is totally fine. To mitigate it, so basically, not to mitigate, but to somehow detect packets in terms of our business logic and our protocol. Hi, 𝙽𝙴𝚁𝙸𝚂. How are you doing? So basically, to somehow mark different messages inside this stream, we prefix each message with the size of this message. So these 2 bytes basically indicate the size of this whole packet. So these 2 bytes convert to number 14, and this message is basically 14 bytes. So if we receive 3 of them in a single packet, we will be able to distinguish. But it may be more complex, so TCP can send like half of the message, and then in the next packet it can send other half of the message. So what we're doing, we receive the packet and we see that the packet is incomplete, so we didn't receive yet our all 14 bytes. So we wait for the next packet. And when the rest arrives, we basically now see that we have the whole packet and we process that. But it can be even more complex. So it can be like we receive 1 packet plus half of the next packet. So we should read this one, process it, and then try to read next one, realize that we don't have the full message, then wait for the next message, for the next packet to read the rest of the message. So, and it can be even more complex than that. So it can be like we receive message and start of the next one in 1 packet, then we receive the rest one in the next packet, plus the whole another message, plus, for example, whole 3rd message, plus beginning of the 4th message. So we should distinguish that, and that logic doesn't work for some reason sometimes. I have a suspicion that it's something to do with the buffer resizing, but I can't point out where the actual problem is. So now I'm trying to catch that inside the debugger. So sometimes with this test, sometimes it appears, but not always. and I don't know yet why. So I'm right now trying to catch this problem under the debugger so I can see what's actually happening. So basically my test case is I send the first message, then I send incomplete second message without the last byte, and then the third one contains the last byte of the previous one plus the whole third message. And sometimes it appears like that. So instead of 3 packets, so each test is 1 incoming packet. I can actually, yeah, I should do that. So I should add this number to the message so I can see what's actually inside. So here we have 4 packets. It should be 3. So we've sent 3 packets, but the server somehow, by receiving the same data, it detected 4 packets. And in the second one was basically a duplicate of the first one. Not sure how that is possible. Okay, let's try and replicate that. Okay, right now it was good. So after 1, we receive this 1. Then 2, we don't receive anything because it was incomplete. Then on the 3, we should receive 2 packets. Yeah, it works, but not always. The thing is, it didn't get sent. So this test program only sends these 3 packets. And combined together, they contain exactly 3 messages, unique messages. They contain number 1, 2, and 3. So it should always be like 1, 2, 3. Never mind this message because yeah, it can appear after the first one. Actually, I can add a small delay so that doesn't happen. So it's easier for me to read. So like, no, even half a second would be enough. So we sent exactly 3 packets, but the server somehow, in the server packet reading logic, there is a bug that makes the first packet to appear twice. So yeah, no idea what's wrong there. So nothing on 2, and 2 on 3, okay. Let's try again. 1, nothing, 2, 3. Let me actually make this smaller so I can see that at the same time. So, works so far. But sometimes it doesn't. So I think I can make it appear more often by changing the recommended packet size to, I don't know, let's try that. So we would have internal buffer of 20 bytes. So I'm pretty sure that happens because of the resizing and copying the incoming buffer. It's just, yeah, it's hard to point that out somewhere. So let's try. 1, nothing, 2, 3, okay. Oh, come on. Now I decided to work every time. Okay, let's revert this setting. Restart. Thank you, and thank you for stopping by. I have no idea why it's not working now. Okay, what's going on? Is it because of the pause here? How can that be? Oh, come on. I didn't change anything. At least I don't think so. Now it's here. What? Pretty sure this is just a coincidence. It shouldn't depend on the pause or something. Don't think it's a race condition. Hello, Dark. Super weird. But what if it is a race condition? How can that happen? I don't understand. Super weird. Why can there be two first packets? Okay, but if I remove everything and just send everything one by one, then it appears. Sometimes. Can I maybe catch that here and trace it back? I'm not sure if I can. Maybe the debugger itself will affect it. Let's try. Here we go. So minus 28. Can I maybe catch that in the debugger? With this thing running? Okay, I can. So looks like it's not the delay. So remaining 28. Remaining 28 is 2 more packets, but we have our first one here. Yeah. So here we marked next packet offset to 14. Received 42 bytes. 42 bytes. 42. Math doesn't work for me. Yeah, 3 whole packets. On the technical side, I'm working alone. Few people help me mostly with the design stuff from time to time. And yeah, very occasionally I have someone helping me with something not related to the server or the client itself, but still something technical. Like I had one person helping me with the identity server, the website basically that has single point of authentication for the whole project. But yeah, mainly I'm working alone. So remaining 14, this is our second packet. Yeah, this is not the case right now. Let's try one more time. Okay, remaining 0. Have our first packet. Then we have remaining 14. This is our second packet. Yeah, this is still not the case. What's happening? 0. $14. 0. Can I actually reproduce this with these steps in the debugger or not? -28, we have all 3 of them. Okay, -13. This is new. So this is our first packet. And 13 bytes is the incomplete thing. So next packet offset is 14. So this is after our first one. Why do we have 27 now? Wait, 27 minus 14. Yeah, this is actually correct. So now, I don't know. But okay, next offset is 14. What's happening next? Million bytes minus 13. So next we read the next packet, which is incomplete. We have one packet remaining. This packet is null because we failed to read it. I mean, 1 byte remains. So now we run this. No, we don't run this. Okay. And then this. Here is our problem. So we have -28. So this indicates after this packet, we still have 28 bytes to read. So this try read fails. Why is it failing? Received bytes 42. This is 3 packets exactly. Why is the next packet offset is 0? Okay, I think I know. Okay, I think I got it. It doesn't matter what is the buffer size. What I need is actually to receive those 3 packets. No, but why is it not working that way? So we had our next packet offset 14. After first packet, after processing the first packet, it was 14 inside this buffer. 1 second. My brain is boiling. So what happens is it resets to 0. But 32 minus 28, I don't know. Also we reset it to 0 when there's 0 remaining bytes. But this is correct. We just start from the beginning. Where is the allocation? Here's the allocation. I need one more step through in the debugger. So let's try with this thing. But why it's not working like all the time? Right now it was exactly like I wanted. Okay, let's try. So we received the first packet. It's full packet. Right? Okay, I think I know what actually may be wrong. So if I combine these two together, right, just to be sure that I don't mess up my test case. Oh. But okay, can I reproduce this all the time now? Okay, now we got it. Second time. Yes. Okay, I think this is our test case that reproduces the problem all the time. This is great. This is just awesome. And yeah, this is actually correlates to what I had in my Wireshark. So this was the remaining byte of the previous packet, then full packet right here, and then the next one, but not complete one. So I needed one message. Right. So this one contains one complete first message, then incomplete second one, and then this contains the remaining of the second one and full third one. Okay, let's see this in the debugger. At least now I think I can reproduce this all the time. I'm pretty sure there's something wrong here. But let's see. So we receive, yeah, we got one packet, the first one, and minus 13 bytes remaining. Okay, we process the first packet. Here we go. Then what happens? Received bytes is 27. Is that correct? Yeah, it's 14 times 2 minus 1. So yeah, this is the whole, this whole stream. So this is correct. Now we do this magic. So 27 plus minus 13, it should give us 14 offset. Yes. And we go next right away. Right away? Yeah. So now we have next packet offset is 14. Remaining bytes is 27, received bytes is 27 still, minus 14. So now we try to read from the 14th byte to oh wait, minus 14. So here we're trying to read from basically offset 14, and this is the length, this is not 2. So the length, yeah, we need to read 14, so this is correct. So 27 minus 14. Hello, keyboard. Okay, 27 minus 14. Yeah, we try to read a packet from the next 13 bytes, which is impossible. At least it should be impossible. So let's see what happens. Yeah, we don't receive the packet. And we still need 1 byte remaining to get the whole packet. Okay. So now what happens is next packet offset is still 14. Remaining bytes is 1. So this loop is finished, and now we lost the next packet offset. Here we go. And this is why we read back from the beginning of the buffer. Hello, Neka. So I think I found the problem. So in the next call, so this is, at this point we finished processing everything that we have received so far. Yeah. Next, when I push the next chunk of data, because we lost this next packet offset, we start from the beginning, from the first packet. Yeah, it's the same offset. And so we get our first packet again. If we process it, we get the error. Yes. Oh, I should have stepped out, so I don't need this breakpoint anymore. So I think I understand what's happening now. So when remaining bytes is more than 0, after we processed one packet completely, how does it work if we have everything here? we reset this thing. So basically we should advance this thing instead when we read the packet. We should always advance this value. So it's not the resizing. It's this, the next packet offset. You need to basically get rid of this. Why do I need this variable? Why can't I just decrease received bytes and increase the offset all the time? I needed this variable to process next packet if we have two of them. But can I do this in a different way so I actually save the state? So where do we assign it? We assign it only here. So it's when remaining bytes is negative, which means we have another packet. Yeah, this is a wrong assumption. It's even stated in the comment. It's not always complete packet. So if remaining bytes is negative, then it can't modify the offset. This is what I received just from the buffer pool. But I need this offset. So this only works if we have two whole packets at the same time. But it fails if we have a portion of next packet. So if we have whole next packet, then we read it and we receive remaining bytes positive. I can just save it in the state. So another variable. So this thing yes. Then if we have nothing more, then we can reset it. Then here we save it. Wait, what is this? Yeah, okay. Now I can remove that. And this should be enough. So where do we reset this? Receive the bytes 0. We need to also reduce this. No, wait. Yeah. So here we copied the buffer from somewhere here to the beginning. Yes, this is correct. So let's check once more. Received bytes. Where do we set this? Here. But this is when we receive new data. This is correct. We don't need to change the read bytes. Then here we reset it to the beginning and read bytes to 0 as well when we finished the reading completely. Then on the resizing. Yes. So let's see if this helps with our test case. Oh, and I don't need this, but okay. Okay, now it works. So if I remove that, yes. Okay, now let's write another test case. So let's do the first one. Oh my god. I'm already confused. So yeah, let's try this. We have first complete packet, then second one incomplete, then we have the remaining of the second one and full third one. Yes. Let's try with the pauses. Okay. Oh, I forgot your name, but this doesn't matter. This one works now. Okay. Now let's try another one. Like here we have incomplete one, and we will have an incomplete one here as well. Right. Yeah. And this. So we received the first one, then we have incomplete packet, then another incomplete packet, and then finish of the previous packet and the third packet. Yeah. Okay, this works. And what else did I want to test? Let's say we want a fourth packet. Okay, fourth. Okay, this works. What else can I test? So can I test like normal packets? All complete packets. Okay, perfect. Then 2 packets in a single, 2 messages in a single packet. Nice. And let's say beginning of the next packet, like one first byte, which is an invalid size. I don't think I tested this. From the third packet. One, 2, 3, 4. Okay. And if we have a complete size, one, 2, 3, 4. Okay, now I think now it works properly. One thing that I didn't test actually is the buffer overflow, that resizing stuff. Actually, I think I tested it when I actually wrote it, but let's test it right now. And let's correct this. Where was that? This comment. Benes, hello and welcome to the stream. How are you doing? So now I wanted to test the buffer overflow. So if I change, where was that? Here. So if I change this to, let's say, our test is 14, let's say 16 bytes. What would happen? Just finished it and good. And I think I just finished one huge bug that was bothering me from the start of the test, and it was really hard to detect. But yeah, let's try and see what happens with the buffer resizing. I think there may be another problem as well. So I need 1, 2, 3. And I need a debugger for that. Oh, wait. I need to restart this first. So now if we run this, so first we receive, what did we receive? Just 14 bytes, right? Yeah, a complete first packet. Here's our packet. Yeah, let me actually add breakpoint here just in case. Then we send the next portion, which is 2 complete packets plus a beginning of a third one. Right? Right. And this should be more than our buffer. Actually forgot to check the buffer size, but okay, let's just see now. So now we receive 16 bytes. Wait, 16 bytes. Oh yeah, this is our buffer size. This is why 16 bytes. -2. Yeah, we read the first 14 bytes and we have 2 left. So here we have our second packet. Yeah, test 2. And we still have, and we have 2 bytes of the next packet that managed to fit into the buffer. So yeah, that would not be a proper test for the resizing. It will never happen. I need just a bigger packet, I think. So next we have read bytes 14. After that we are trying to read, yeah, we failed to read packet because only 2 bytes are left in our buffer. So now we have 8. No, actually there will be resizing. Not resizing itself, but reordering of the bytes. So this is cool. So now we still need to read 8 more bytes. We don't have a packet here. So we go here. So received bytes 14 plus remaining bytes 8, yeah, is more than our buffer length of 16 bytes. So now what would happen? Next packet size is 10 bytes. What is the next packet size? So received bytes minus read bytes, this is 2, plus remaining bytes 8. Why remaining bytes is 8? Okay, because of the buffer size. So now we do the reordering. So this shouldn't run, I think. 10, yeah. 10 is not more than 6. Now we just move the bytes at the beginning of the buffer. So received bytes now is 2. And read bytes is reset to 0. And now we copy the original buffer of set plus read byte. This is a bug. This assignment should be later, because this always will be 0. So this is definitely a bug. But how did I manage to actually read this? Okay, there is a bug, but I actually managed to read this somehow. Probably with another round trip here. No, wait. Source. It shouldn't have worked. It should have debugged it more. But yeah, let's try now. Still works. So yeah, probably there was like another unwanted restructuring of the buffer. So okay, let's debug this now. So here we receive 14 bytes, our full first packet. Have 0 bytes remaining to read, we have our packet. and we reset the received bytes to 0 and read bytes to 0. And this is end of our process right now. Then let's send, so here we have 2 full packets plus the beginning of the second one, of a third one. So here, this indicates that we have still something remaining in the buffer. So we have our packet, we process it, now we have this thing. So received bytes is 18, which is the size of our buffer, and remaining bytes is -2. So we set this to 14. Yeah, so this is right after our first packet. Now what happens? We're still here. We try to read it once more. Now we know the real size. We still need 8 bytes to read. Why 8? The packet should be 14 bytes. But okay, this really doesn't matter because we will still need to read it. So here we have to adjust our buffer so we can actually read the next packet. So for some reason, protocol thinks that there is a packet of 10 bytes. But okay. Next packet size is 10. Now we store the buffer. We can still fit the data in the buffer, we just restructure it. So received bytes, we decrease received bytes by the read bytes. So we basically move everything back by this value, by read bytes. So received bytes is 2. So we need to copy 2 bytes from this position to the beginning. So we have our source buffer. And yeah, this is the position, right? The source offset. Come on, where is my help? Yeah, source offset 14, which is correct. And we copy this to this buffer, which is the same one in this case, but to the root offset, to the 0. And we copy just 2 bytes. Yeah, this is correct. And then we reset read bytes to 0. Because yeah, we are never processed this this packet. What's next? Yeah, this is not triggering because we never actually acquired a bigger buffer. So remaining bytes is 8. And yeah, this is the finish of this particular process because we actually need to call the network stack to read it once more. And here we go. So read bytes is 0. Received bytes now 16. It was 2 previously. plus 14 that we retrieved. Yeah. So this is 16. We read a full packet and we know that there is 2 more bytes at least of the next packet. So now this should become 14. So yeah, right after our current packet. Next, what happens? We read. Oh, this is the same one. So we still need 8 bytes. We couldn't read it. And this is resizing again, because we will not fit into that particular buffer. Okay. We do our resizing, reordering. And we're done. And then the next read call. Still we failed to read. Oh, probably we was still there. Oh, no. All good, because now we processed 2 packets, like first one, then 2, like 2 and 3, and then we have the beginning of the 4th one, and now we wait for it. And when we send it, yeah, now we read it completely. Okay, so this works. Now, one strange thing still is, why did we detect like 10 bytes packet size inside the protocol? Because we can, wait. Yeah, weird. I want to check that as well. Let's do this. So, let me see. First we send the complete second packet. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, yeah. Then complete third packet, and then 2 bytes. Oh, okay, I get it, I think. So we have 16 byte buffer, 14 byte packets. So this one fits, and plus 2 bytes here. No, still I want to check that. I don't understand how that was working. So if we run it again. So here we receive our complete first packet. Yes. We can skip this. Then we send this chunk. Okay. So here we have our first packet and 2 bytes remaining from the next one, because only 2 bytes fit into our buffer. This is correct. We process the number 2 packet, yes. And now we know that there is still something left. So we use the same buffer, but we move our pointer after our packet. Yes, now it's 14. And we try to read immediately after that. So it should read the whole size portion, which should be 14. Minus 2 that we read, it should be 12. So it should be remaining 12 bytes. It says remaining 8, so I need to check that. Let's stop this debugging. Let's finish. So this is incorrect, I think. Now I need to understand why this is incorrect and can it cause any problems. So this is our first packet, this is fine. Then here we have second packet, 2 bytes remaining. Can skip this. Now I need to, so yeah, this is our offset. 16 minus 14, this is 2 bytes. We can only read 2 bytes. Let's step into that. So here our offset 54 and 2 bytes. Oh, mean packet size is 10 bytes. Okay. Yeah. This is fine. But yeah, wait. Oh, okay. If I would set it to 2 bytes, then this logic would be working properly. But yeah, I need this to be greater to read the header. So yeah, this is why there was 8 bytes. Yeah, it goes here. And yeah, it wouldn't cause any problems. Just maybe on some extremely large packets it will cause the packet to first move to the beginning of the buffer and then resize, which would cause additional copy, but this is fine. That would theoretically never happen. Well, theoretically it can happen, but practically never. Okay, I think this is it. This bug is fixed. Now what I wanted to do is to try and run a test. So first, let's stop debugging. I don't need this anymore. And wait, this is libuv, but also I have a TCP connection. Where is that? Connections, TCP connection. I think this has the similar logic, yeah. So I need to fix that as well. This is basically the same, which is wrong. So, and also I wanted to rename this, I don't like it. So it will be bytes received and bytes read. And the same goes for this TCP connection. Actually, let's first rename this. Bytes received, then bytes read. Now I need to duplicate this fix that I did. So remove that. We use 𝙽𝙴𝚁𝙸 instead. Here and here. We reset 𝙽𝙴𝚁 here. No. Oh yeah. Yeah, this is true. Then here we have this thing. And let's fix the comment. This one is different. Okay, it doesn't have this optimization that I've done for the libuv. Okay, which means I need to do this in a different way. And actually this one doesn't need it. Doesn't need this fix. Okay. This is nice. This one is actually works. So when I added this optimization with buffer allocations for bigger packets, I broke it. Okay. So let's commit this thing first. Now I need this. Yeah, I need to check out master here. And push this. Now the networking test branch. Let's merge master into it. Then pop our stash. Yeah, this should be fine. Now I can revert this packet size. And I can revert this change as well. I don't need it anymore. And now let's deploy this test. Now hopefully it will actually fix the problem with the client. Actually forgot to run the release build. Yeah, this is fine. Now I need to wait for the deployment. Actually, while I'm waiting, I think I can test. Oh, what is that? Oh my god. No idea. But yeah, now I think I can test the client locally at least, while my test server is deploying. Okay. Test one more time. So I have this test, which is which runs when the client connects. And all the checks are finished. It basically sends 1000 ping packets, and the client have to respond with 1000 ping packets in correct order. So yeah, it did pass this test here, but this is just a local connection. This is fine. This happens sometimes. Actually, do I have any errors here as well? Good. I need to hide this for now. Okay, at least locally it works. Let me run the rest of the server and see. Hopefully I didn't mess up anything else. Okay, good so far. Where is my deployment? It's still running. Okay, let's test one more time. Okay, so far so good. Okay, deployment is almost done. Why is it so slow all of a sudden? Okay, it's done. Oh, I still need to deploy that. Okay. Okay. Now let's test this. Okay. Yeah, I can't log into the vault, but it's fine. Let's test this one more time. It actually fixed itself. I mean, it actually is fixed now. Session ID is okay. That is expected. Okay, I think this works now. This is perfect. Now I need to deploy this to the actual server and see if it works. Yeah, so yeah, now I think I fixed the actual problem, and I need to deploy it to production server, which I'm not gonna do on stream. So I think this is it for today. Thank you everyone who was watching, and let's find someone to rate. Actually, I know who to rate. Let's rate Bennett again. He just started streaming. So yeah, let's see. Hopefully tomorrow I can stream again, and hopefully something more interesting than just bug fixes. But yeah, this bug had to be fixed. This is a very critical one. So yeah, thank you everyone for staying. Thank you, 𝙽𝙴𝚁𝙂. Yeah, let's go raid Bennett. Bye bye.